In problem number 1, we have an operational amplifier, and we're told the following information about it. It has a gain bandwidth product of 2 pi times 10 to the minus 7. Omega t is 2 pi times 10 to the 7th. And these would be radians per second. It is used in inverting mode. This is an inverting mode. And in this inverting mode, we're told that the feedback resistance is 25,000 ohms and the input resistance is 5,000 ohms. The question is to find the gain and the bandwidth of the circuit. So we're looking for 2 parameters, the gain and the bandwidth. Now, if this is the input voltage, Vn, and this is the output voltage at this point, we know that the voltage that is present across these 2 terminals would be equal to, this is grounded, but a voltage across here would be equal to V out divided by A sub 0. This would be the negative end, this would be the positive end. That's the voltage differential between those 2 inputs. This current going to the amplifier we know is equal to 0. I equal to 0. Now, if we write Kirchhoff's current law at the node, this node, we can write that the current flowing in from left to right would be Vin minus the voltage at that point, which would be V out over A, and this is divided by 5,000 ohms, and that current added to, let's assume that the current is flowing in this direction through the feedback impedance, that current would be equal to V out, and we're going to have plus, this will be a plus sign, of course, because the way we did the polarity here is minus and minus. So this voltage at this point is minus V out over A0. This becomes V in minus a minus, which makes it V in plus. So this becomes V out minus a minus, makes it plus. This is V out over A, and this is divided by 25,000 ohms, and this is equal to 0. The next thing we take, and next thing we use here, is the fact that A, the amplifier gain, is equal to A0 divided by 1 plus S divided by omega sub B. This was a definition given earlier in the chapter. So we see that this is actually the constant or the DC gain, and then of course it rolls off and depends upon the frequency omega sub B. Now if I were to put this expression for A into this upper expression, first let me do this. V out over A, which appears a couple different places up here, would be equal to V out times 1 plus S over omega sub B divided by A0. This V out over A. If I were to take this expression and make the following change in this, let's divide the A0 into this, I have V out times 1 over A0 plus S over A0 omega sub B.